Welcome to our channel. In this video, we will talk about slope of a line. We will define slope of a line. We will look at what exactly we mean by slope of a line. We will derive formula for the slope, and then we will look at some examples. So here is the definition of slope of a line. Slope of a line basically measures the steepness of the line. It is the rate of change in y with respect to x. So basically slope is change in y over change in x. How fast y is changing as x is changing. So in this graph here, if we look at these 2 points, x1, y1 and x2, y2, the slope of this line is change in y over change in x. So let's figure out what change in y and change in x would look like. So change in y is this length over here. So to get that length, we can look at the y values. The y coordinate of that is y2. So that value must be y2. And y coordinate of that point is y1. So that value must be y1. And that distance is y2 minus y1. That means this change in y is y2 minus y1. So change in y is y2 minus y1. And similarly, we can find change in x. Since the x coordinate of that point is x2, this would be x2 over here on the x-axis. Since the x coordinate of that one is x1, this would be x1 here on the x-axis. So that gap is x2 minus x1. That means change in x is simply x2 minus x1. So this is the slope of the formula, y2 minus y1 over x2 minus x1. All right, so let's look at some examples next. So here we are given 2 points, 12, -1 and 3, -3. So we want to find the slope going through those 2 points. Let's quickly plot those points and see how they look like. 12, -1 would be a little outside the graph. So let's say it would be somewhere over here, 12, -1. And 3, -3 is going to be somewhere here. So we are looking at the graph of the line going through these 2 points. We can use this formula here, y2 minus y1 over x2 minus x1. So we can say the first pair is x1, y1, and the second pair is x2, y2. Then slope of this line will be y2 minus y1, so -3 minus -1, and x2 minus x1, 3 minus 12. So this is the slope. Now the rest is just simplifying. -3 minus -1 would be -3 plus 1. Divide by 3 minus 12 is -9. So this becomes -3 plus 1 on the top is -2 over -9. So the slope is 2 by 9. So this describes how fast the y value is increasing with respect to x. Here we have another example. We have a line containing these points. Let's quickly plot them. 2, 1 is right here. 3, 3 is right here. And 4, 5 is right here. So we are looking at this line going through those 3 points. So it will look like this one. Right, so now we are ready to find the slope. We can use this formula, y2 minus y1 over x2 minus x1. Now, if you look at this formula, we need just 2 pairs. So we need 2 pairs of coordinates. We need x1, y1 and x2, y2. So we can use any 2 of these 3 points and you'll get the same slope. No matter which 2 points you use, you get the same slope. So let's try using this point here as x1, y1, and let's use that point as x2, y2. So using those 2 points, slope would be y2 minus y1. So 3 minus 1, x2 minus x1, 3 minus 2. So 2 on the top and 1 in the denominator. So slope is 2. Now instead, if you choose to use the other 2 points, 4 and 5 as x2 and y2, let's see if we get the same slope. So slope will be y2 minus y1, 5 minus 1 on the top, divided by 4 minus 2 in the denominator. So you get 5 minus 1 is 4, divided by 4 minus 2 is 2, which is 2 again. So no matter which 2 points you pick, you get the same slope. So the slope of this line is 2, which is the rate of change of y with respect to x. Next, we have this example. This time we are given an equation and we want to find the slope. So when equation is given, there is a nicer way to find slope by looking at the format of the equation, but we will do that in our next video. So here we will still use this formula. Slope equals y2 minus y1 over x2 minus x1. For that, we need any 2 points on the line. So that's easy to find. Let's figure out any 2 points on the line. When x is 0, we have negative 3 times 0, which is 0 plus 5. So you get 5. And another point we can use, let's say when x is 1, you have negative 3 times 1, which is negative 3 plus 5, so 2. We get these 2 points, 0, 5, and 1, 2. So these are all we need to find slope of the line. So let's call the first pair x1, y1, and call the second pair x2, y2. So before we find the slope, let's try to graph this line. Since we have 2 points, that shouldn't be too bad. So 0, 5 is right here, and 1, 2 is right here. So it's a straight line going through those 2 points. Of course, it extends indefinitely at both ends. So now let's find the slope. So slope, we can use this formula, y2 minus y1 over x2 minus x1. y2 is 2, y1 is 5. So we have 2 minus 5 for y2 minus y1, and 1 minus 0 for x2 minus x1. So this becomes negative 3 on the top over 1. This is negative 3. So the slope of this line is negative 3. The slope is negative here since it's sloping downward. So as your x values are increasing, the y value is going down. Next, we have y equals 5. So again, let's try to quickly graph this. So y equals 5 is a horizontal line at y value of 5. So we can easily graph this equation. So this is the graph of y equals 5. Now to find the slope using this formula, we need 2 points, x and y. So when x is 0, y is fixed to be 5. And when x is, let's say 3, any other value, y is 5. We need 2 points. So 0, 5, and 3, 5. So we can call the first pair x1, y1. So this is x1, y1, and we can call the second pair x2, y2. So now we are ready to apply this formula. Before we do that, let's look at the graph of this equation. A graph is a horizontal line. Earlier we said slope is steepness. If we look at this graph, what is the steepness here? There is no steepness at all because it's a flat horizontal line. It's not steep at all. So the slope would be 0. And that we can verify by using this formula. So slope is y2 minus y1, 5 minus 5, divided by x2 minus x1, 3 minus 0. So 0 over 3, which is 0. 0 divided by any number is 0, so slope is 0. So for any horizontal line, slope is always 0 because it doesn't have any steepness at all. Let's look at next example. We have x equals 2. So let's first graph this equation. The graph of equation x equals 2 is a horizontal line at x equals 2. So this is the graph of x equals 2. Let's try to find the slope of this line here and see what we get. So for that, let's try using this formula. And to use that formula, we need any 2 points. So it's a vertical line. So x is always 2 in this case. And y value can be anything like 3 and 6. So you can put down any number for y values. So 2, 3, the first point is right here, and 2, 6, the second point is over here. We can call the first pair to be x1, y1, and call the second pair to be x2, y2. Now we are ready to apply the formula since we have x1, y1, x2, y2. But before applying the formula, let's again think about what we mean by slope. We said slope is steepness of the line. If you look at this vertical line, what is the steepness? It's very steep. It's so steep that we can't measure the steepness by a finite number. So this is undefined. So the steepness of this vertical line, any vertical line, is undefined because it's very steep. It's not measurable by a finite number. Let's still try to apply this formula and see what that gives us. So y2 minus y1 is 6 minus 3 in this case, 6 minus 3, and 2 minus 2. So we have 3 over 0. We can't divide by 0. Anytime you try to divide by 0, it becomes undefined. So the slope of any vertical line is undefined, which basically means it's very steep. It's so steep that we can't define the steepness using a finite number. So from the example we just saw, we can say that slope of any horizontal line is 0 and slope of any vertical line is undefined. No matter where you draw the horizontal line, it has slope 0. And no matter where you draw a vertical line, it has slope undefined. Right, so this is all we have in this video. We will talk more about slopes when we talk about equations of line in our next videos. Thank you for watching and have a good day.